Good morning everyone. Today we are going to solve this LeetCode problem, which is minimum bit flips to convert number. Okay, so when I'll show you the solution, you won't like it, but anyways, the question is easy, and a bit flip of a number x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. So we'll see this test case in my notebook. But anyways, given two integers, start and goal, return the minimum number of bit flips to convert start to goal. So it's a question of bit manipulation, and for this you need to understand some bitwise operations to actually know what is actually happening here. So from 10 to 3, if you start from 10 and you have to convert it 7, you have to do at least 3 bit flips to actually get the number 7, right? Similarly, for 3 to 4, the answer is same, and we'll actually look at the demonstration in a moment. But look at the constraints. Start to goal, all of them can be stored in a 32-bit integer. Okay, so here we are in my notebook, and let's see how do we actually do this, right? So first of all, we need to convert this to a binary integer to actually understand. So 10 can be written as 10 10 and some leading zeros, right? Which is I'm not showing. 1 0 1 and 0. And how do you write a 7 in binary? 7 in binary is 111. And just to make them of same size, I'll just append a 0. If you see, this is 10 in binary, this is 7 in binary, and now you have to tell me how many bits you have to convert from this to this, right? So you see, we want 0 in this place, but we have 1. So do we switch the value from 1 to 0? And the answer is yes. One switch here. Again, this is 0, but we want 1 at this place. So again, we have to switch the value. Similarly, you see 1 is already here, so we don't have to perform a switch. So we don't perform a switch. Now we have 0 here, we have 1 here, so we have to perform a switch. So we have to perform a switch. Now keep this in mind. This would have zeros in the front, so we won't be having any switches in between in this 0 port. So now just count the number of ticks, which is 3, and therefore your answer is 3 for this test case. Similarly, let's look at from going to 3 to 4. So what is 3 in binary? 3 in binary is this, and 4 in binary is this. 3 in binary, 4 in binary. Okay, so since there are no numbers, I'll just place 0 at this position, and you see these two are not matching, so switching is required. These two are not matching, these two are also not matching, so switching is. So again, if you count these, again your answer would be 3 in this case. Just one more sample test case. Let's say we have 6, and so 6 is 110 and another 6 is 110. So you see, obviously these are the same numbers, they have same bit representation, so no switches. So in this case, answer would be 0. Now, okay, we understand we need to find out the number of elements which are differing in the original and the start and the end. Now what I could do is, let me just copy this. So given this, I want you to know about the XOR operation. So 1 XOR 1 is what? 0. 0 XOR 1 is what? 1. 1 XOR 0 is also 1, and 1 0 XOR 0 is, so this value is 0. XORing any two bits is 0 if they both are the same bit. Otherwise, if they are different, in this case the answer is 1. So that is the XOR operation. And let's say if you apply, let's say start XOR end, so the XORing would be done bitwise. XOR of this and this would be placed here, XOR of this and this would be placed here, XOR of this and this placed here, XOR of this and placed here, and so on. So what actually the XOR? So if you see, the starting elements are all zeros, so 0 0 XOR 0 is 0 0 XOR 0. So the first few elements 0. Now 1 XOR 0 is what? 1 XOR 0 is 1, so my answer would be 1 in this case. 0 XOR 1, this is also 1, so the answer would be 1 in this case. 1 XOR 1, so 1 XOR 1 is 0, so the answer would be 0 in this. And again, 0 XOR 1, 0 XOR 1 is 1, so answer would be 1 in this. Now if you see, the number of ones in this is actually what? This is actually the number of set bits, which the bits which has the value of 1 is actually our answer. See, we have 3 set bits, and that is why the answer is 3 for this case. Similarly, you see this 1 1 and 1. If you take the XOR 0 1 1 1 0 1 1, the answer would be 1 1 1. So the set bits is 3. So again, the answer is 3. Okay, so we know that if we do this operation, we would get a number which has the number of the answer to the problem would be the number of set bits in this value. Okay, now we have to figure out the number of set bits. Now figuring out number of set bits is what you do is you take the value 0 and perform an XOR operation with it. And if the answer is 1, you increase the counter by 1. So let's say 1 1 0 1, and what I do is I take XOR with 0. So what will be the answer? I take XOR, so this 1 0, sorry, not XOR, we perform, we'll take this 1 0 0, the value of 1, and do the AND operation. The AND operation, 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 0, 0 and 0. This is the AND operation. So what I'll do is I'll take the AND of these two numbers bitwise. So what I would get is this value is 1 0 0 0. So what I'll do is I'll say count plus plus, right? Now what I would do is I'll take this number and I'll do a right shift up. So 1 1 0. So basically right shifting is saying that place the 0 here, place the 1 here, place the 1 here. All the leading zeros would be shifted to one place to the right, and the last bit would be 0. So now we have 1 1 0. So what I do is I take the AND with 1 again. In this case value is 0, so I don't do anything. Again I do a right shift, so I'll have 1 1 and take AND with 0 1, which is 1, and I'll get a value of 1. So I'll say count plus plus again. So my counter value was initially 0, now it's 1, then 2. Now again I do a right shift 1 and I take AND with 1 itself. Again when I do this, get the value of 1, I again increase count plus. I have done it for 3 times, and now when I shift this, the value would be 0, and any number which is ANDed with 0 would be 0, so stop at this position. Okay, so that is how we got the value of 3. Definitely I've shown you a lot of weird stuff you may or may not be comfortable with. Maybe if you're comfortable with counting set bits and taking the XOR, you are done with. Now let us see how I have implemented the code. So before you dislike this video after seeing the solution, please keep that in mind. Never to reinvent the wheel. It is already present. Don't try to rebuild it. So the solution is this, and I know this is like quite straightforward. So now let me just explain what everything is happening. So start XOR goal that I have shown you. So this value, whatever this may be, this would give you the number of, so the number that you would get, and if you count the number of set bits, it will be actually your answer. Now what you do is there's a built-in function which is underscore built-in underscore pop count, which will calculate the number of set bits in your answer. And if you observe, built-in pop count would take constant time, and XOR operation will also take constant time. So this is a constant space and constant time solution. So big O of 1 space, big O of 1 time, and it's simple. I don't know, like I've even posted a solution if you want to check this out, but that was the whole video. It's definitely and beats 100%, right? So yep, and this was the whole video, and I'll see you in the next one.